Hello guys, so welcome back to our VHDL lessons. We're gonna continue our discussion about decoders. So in the previous two videos, we explored the two designs for basically the 2x4 decoder with enable and without enable input. Here is, the first design that we can use to implement basically this decoder in here. It has no, enable input. It's really easy to, to extend it by adding the enable input. Okay, and here is, the code for it, the VHDL code for it. So basically, you have three inputs here: X, Y, Z, and you have eight outputs from D0 until D7. And here is basically, the relation of each, output to the input. For example, D0 is X prime or X complement, Y complement is Z complement. Okay, and so on for the rest of the outputs here. And here is, the code. It's really easy. It just, explains each, or explains this basically design using its gates. So for example, the zero is X complement, not X, and Y complement, not Y, and not Z or Z complement. And the rest is the same. Again, for example, if we take D4, it's X and Y complement, or not Y, and not Z or Z complement. Okay, and the rest is very same. So of course, this is called I'm calling it design one, because again we can use the new statements that we learned from VHDL from the last video to implement the same circuit, but in using the truth table to describe the truth table, okay, which is the select when statement that we learned last time. Okay, so for example, if we explode it, where it is, yeah, this guy. So basically, you can do the same using using this technique here, or using this with select statement. So for example, the output here, let's call these outputs are in one variable. This variable or this output is 8 bits from 7 down to 0. So y, the output, which is the 8 bits now, will be equal to 1 0 0 0, then for another 4 zeros when the inputs are 0 0 0, and so on. Okay, so that would be basically the idea if you want to implement the same circuit using with select when statement. Okay, so let's go back to our circuit in here. So after implementing it like this, okay, then we're gonna test the we're gonna also explore the test bench. Here's the test bench. You have here the 3 inputs and the 8 outputs. I'm sorry. And here you defining signals just equal to the the number of inputs and outputs you have. Then you port map them, or you connect these signals to the inputs and the outputs. Then here you are defining a for loop, nested for loops. You have 3 inputs, so you're gonna loop over their possible values. Basically, each input can be either 0 or 1, so it's really easy. And this is the new technique that we learned also in VHDL to loop over a standard logic. So here you are defining a standard logic variable, okay, and you give it a range from zero, the range of the loop from 0 to 1. Basically, since it's a standard logic, you must put this single quotation in here. Then you assign it to the signal xn as another counter, another standard logic counter, and you assign it to yn. Then a third and last one, k here, another standard logic counter, and you assign it to z. Then let's simulate this. It's called the 3x8 decoder, 3x8 test bench. This guy. Here we have still 8 possible outputs. So let's run it. And let's zoom in as usual. Or zoom out, I'm sorry. So when you have 0, 0, 0 at the input, this is D0. That's why you have 1 here at D0. Then when you have 0, 0, 1, you have D1. Look, D1 is 1 now. And so on, look. It's again, the diagonal shape. So it's going down, down until you reach D7. So when the inputs are, I'm sorry, here is D7. When the inputs are 1, 1, 1, look, 1, 1, 1, the output D7 is 1, and the rest, all the rest are zeros basically. Okay. So that's it, guys, for the, for the 3x8 decoder using, behavioral coding. And your assignment basically is to do same code, this code in here, but using the with select when statement, okay, which describes basically the truth table. Okay, it should be easy. You just take the 2x4 and try to extend it. And I don't want to enable input, and just use what you have. I mean XYZ and 8 outputs, D0 until D7. Thank you very much, guys, for watching this video, and see you in the next video. Bye-bye.